Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting my video on the topic curve tracing. First type, Cartesian curve tracing. First example, trace the curve y square into a minus x is equals to x cube with full justification. Therefore, to trace this curve, we have to follow the working procedure or the steps. Step number 1, we have to check the symmetry. As I had discussed in the earlier part of the video, here power of y is 2 even, as power of y is even. Therefore, the curve is symmetrical about x-axis. Means whatever the curve we have to draw, it is symmetrical to x-axis. Second point, origin and tangents at the origin. Origin and tangents at the origin. In this point, we have to check whether the curve passes through origin or not by following this procedure. Put y and x at 0. Therefore, if we put y equals to 0, left hand side becomes 0. If we put x equals to 0, we get x right hand side at 0. And as we get 0 is equals to 0, therefore, curve passes through the origin, and as it passes through origin, we require to find tangents at the origin. Therefore, to find tangent or tangents at the origin, we have to equate lowest degree term to 0. Therefore, we try to find out the degree of each and every term. The degree of first term is 2, degree of second term is 3, and degree of third term is 3. Therefore, the lowest degree term is ay square, whose degree is 2. Equating it to 0, it implies dividing by a throughout, we get y square is equals to 0. It implies y equals to 0 and y equals to 0. That is, x-axis is the common tangent or repeated tangent, and as it is a common tangent or repeated tangent, therefore at origin we get cusp. Okay, this is the second point. Then the third point, point of intersection. with axis. As the curve is symmetrical to x-axis, we get the point of intersection with y-axis, and for that we have to put y is equals to 0 in the equation. And therefore, if we put y equals to 0, left hand side is 0, we get 0 is equals to x cube. It implies we get x is equals to 0, and therefore that point of intersection is x0 when y0. Therefore, only the origin is the point of intersection. No any other point of intersection. And as no any other point of intersection other than origin, no question of performing that point change or shifting of origin. Here that point is not required, as we get only origin as a point of intersection, no any other point. Point number 4. Asymptote. Here the curve is symmetrical to y-axis, x-axis, and therefore whatever the asymptote we have, it is parallel to y-axis. Therefore, we require to find asymptote parallel to y-axis, and for that, find the highest degree term in y. The highest degree term in y is y square into a minus x. Its coefficient is a minus x. Equate that coefficient to 0. It implies we get x is equals to a line parallel to y-axis as the asymptote. This line is the tangent at the infinity point, and therefore we try to show all these points, whatever 4 points I have discussed in the figure. And the last point is region where curve exists or where curve does not exist. As the curve is symmetrical to x-axis, we have to solve it for y. Therefore, solving for y, we get, therefore we get y square is equals to x cube divided by a minus x. Okay, and then try to get the values of x for which this becomes negative. Therefore, if we consider there are two terms of x, one is in the numerator, another is in the denominator. Therefore, if you consider this term from numerator, if x is less than 0, y square is negative. That is, if you take the square root on both sides, we get root of negative term as imaginary, means curve does not exist for x less than 0. And the second, another x is there in the denominator. If we consider this term, from that term we have, if x is greater than a, means suppose 2a, 3a like this. If we put x is equals to 2a here, a minus 2a, we get negative. Y square is negative. Y is imaginary if we take the square root of this negative term, and therefore curve does not exist. Means curve does not exist for negative values of x, curve does not exist for the values of x for greater than a. Means whatever the curve exists, it is in between x is equals to 0 to x is equals to a. That is curve exists between two lines x is equals to 0 to x is equals to a. And therefore after all this discussion, we have to convert this discussion into figure, or using all this information to trace that curve. Therefore, whatever the points I have discussed, we try to show it in the figure. X-axis, Y-axis, origin, where to trace that in Cartesian coordinate system. Cartesian coordinate system is XY coordinate system. First point we have discussed, curve is symmetrical about x-axis. Therefore, whatever the curve we have to draw, it must be symmetrical to this x-axis. Second point we have discussed, curve is passing through origin. Therefore, origin is the point through which curve passes. Then we have obtained the tangent at the origin. The tangent at the origin is x-axis. Therefore, this x-axis is the common tangent. And as this is common tangent, this point origin is called as cusp point. This is a double point, and the type of the double point is a cusp. Then the third point we obtain point of intersection. The point of intersection is here only the origin, no any other point of intersection. Fourth point we have discussed asymptote, and asymptote here is the line x is equals to a. Therefore, we show that line, suppose this much distance as a, therefore this line x is equals to a we call as asymptote. Asymptote means a line which is tangent at point of infinity. Therefore, that to show that point of infinity is not possible here. Therefore, in that way, we make a part of the curve as parallel to this line. Okay. Therefore, whether we have to show on left hand side or on the right hand side of this line, for that way to go for the last point region. Here curve does not exist for x less than 0, means on this left hand side of this y axis curve does not exist. Second, if x greater than a, on this side, right hand side of this line, curve does not exist, means whatever we have to draw, it is in between these two lines. This is the region of the curve where we have to trace that curve, where we have to draw that curve. And therefore, as this line is asymptote, means it is becoming tangent at infinity, we use that indirect method, make a part of the curve as a parallel, and the same on the lower side. When we make a parallelness between the curve and that line, means it will touch this line at point of infinity. At origin we are getting a cusp, therefore cusp means a pointed shape, therefore make a pointed shape. This type of shape is called as a cusp. And then curve exists between x is equals to 0 to x is equals to a, means for all the values between 0 to a, some values of y we have. Therefore, no need to plot the point. We have to join this part with this part smoothly. As this is not a linear curve, don't join it by straight line. We join it smoothly. This is the half part of the curve, and the curve is symmetrical to x-axis. Therefore, whatever the part I have drawn, I will draw a symmetrical part about x-axis, and therefore this is the curve as shown in the figure. This is called as the tracing of that curve. Important one is here, whatever we are discussing, the same must be reflected in the figure, and you have to draw the figure by pencil and scale. Don't draw it by a pen. With correct labeling, proper labeling, and size of figures should not be too small or too big. It must be in proper size. Therefore, once again I will repeat the points, whatever 5 points I have discussed. The symmetry of this curve is symmetrical about x-axis. Yes, whatever the curve I have drawn, it is symmetrical to x-axis. Curve is passing through origin. Yes, it is passing through origin, and two parts of the curve passes through it. This is one part, another part. Therefore, that point is called as a double point, and the type is cusp. X-axis is the common tangent to this. Therefore, to this part, this line become a tangent. Yes, single point of contact. And to this part, the same line is a tangent. Point of intersection, only origin is the point of intersection, no any other point. Fourth, asymptote. Here we get asymptote parallel to y-axis, and that line is x is equals to a. Therefore, with some suitable distance, I have drawn this line which is parallel to y-axis. And as this is asymptote, we have to make a parallelness between the curve and that line. Therefore, I have drawn here a parallel part. And the last point, origin, curve does not exist for negative values of x. Curve does not exist for x greater than a. Means whatever the curve we have to draw, it is in between these two lines, y-axis and the line x is equals to a. And therefore, if you complete all this in the figure, whatever the figure we are getting, that is called as the tracing with full justification. Means for each and every point we have given the justification. Why it is symmetrical about x-axis, we have given the justification. Why it is passing through origin, yes, we have given the justification, and like this. Therefore, we have to discuss total 5 points, and after discussion, convert that 5 points into proper figure. That figure is called as the tracing. Therefore, this is the first example through which I try to explain how we can obtain the tracing of that curve. Generally, this type of question is asked for 5 marks, and the scheme of marking is like this. For discussion, you will get 3 marks and 2 marks for the figure. If you do it completely, then only you will get 5 marks. If something is wrong, marks will be deducted. Therefore, let us say another example. X square plus 4a square is equals to 8a cube with full justification. Okay. Once again, it is in terms of x and y, means it is Cartesian explicit type, because we can express y in terms of x. Therefore, applying that 5 points procedure, first point, we have to check the symmetry. Out of that 4 symmetries, which one exists here? Here the power of y is odd, therefore curve is not symmetrical about x-axis. Power of x is even, as power of x is even, therefore, or then curve is symmetrical about y-axis. This time curve is symmetrical about y-axis. Therefore, here I will show this simultaneously, whatever the points we are getting. X-axis, y-axis. Therefore, this curve is symmetrical to y-axis. Then second point, we have to discuss origin and tangents at the origin. Complete the procedure. or check the first step. Put y and x is equals to 0. Therefore, if we put y and x as 0, left hand side is 0 and right hand side is 8a cube. Not equal means curve does not passes through origin. This curve is not passing through origin. Then no question of finding the tangent at the origin as it is not passing through origin. Then we go for the third point, point of intersection. Point of intersection with axis. As the curve is symmetrical to y-axis, we get a point of intersection with y-axis. For that, we have to substitute x is equals to 0. Put x is equals to 0 in that equation. Therefore, if we put x is equals to 0, we get y, this term becomes 0, into 4a square is equals to 8a cube, and dividing by 4a square we get y is equals to 8a cube divided by 4a square. We get 4 to the 8, 2, a square cancel with that a square, it is 2a, and therefore that point of intersection is when x is 0, y we get as 2a. Therefore this is the point of intersection on y-axis. Therefore try to show that point of intersection. Suppose this much is a, and approximately this point x0 when y, then y we get y as 2a. Therefore 0 to a is the point of intersection on y-axis, and to obtain the shape of the curve at this particular point we have to shift the origin. As we are getting some point of intersection other than origin, then always we have to perform this step. Therefore shifting of origin. To point 0 to a. Suppose the original coordinates of that origin are xy. From this we have to shift it to 0 to a. In the process, change in x coordinate is x plus 0, that is x, and change in y coordinate is y plus 2a. And as curve passes through this point, it will lie on that curve, and as it lies on that curve, it will satisfy that equation, and therefore we get the equation as y means here y plus 2a into x square, x as it is x square, plus 4a square and that is equals to 8a cube. Then to find the tangent at this point of intersection, we have to obtain the lowest degree term or terms. Therefore try to check the degree of each and every term. The degree of first term is 1 plus 2, that is 3. Degree of this is 1. Degree of this one is 2. Constant term no degree. Constant term no degree. Therefore what is the lowest degree term here? It is 4a square y. Equate that to 0 it implies dividing by 4a square, we get y equals to 0. Y equals to 0 means x-axis as the tangent, but a new x-axis. Therefore, I will draw a new x-axis, a line parallel to x-axis. This line is the tangent at this point of tangent means single point of contact, and as this line is tangent, whatever the shape we have to draw, it must be slightly parabolic, whether it is below this line or above this line, that we will check in the last point, origin. Therefore, whatever I have discussed, all I have shown in this figure. Then we go for the point number 4, asymptote. Point number 4, asymptote. Here the curve is symmetrical to y-axis, means we get whatever the asymptote, if exists any, it must be parallel to x-axis, and we apply the procedure. To find the asymptote parallel to x-axis, try to get the highest degree term in x, only one term of x, that is x square. Then its coefficient is y, equate that coefficient to 0. Therefore, y equals to 0. Y equals to 0 means this x-axis is the asymptote, means this become tangent at infinity, and therefore we use the indirect way. What is indirect way? We have to make a parallelness between that curve and this line. Therefore, I will draw here a parallel, whether it is above this or below this. For that, we have to go for the last point, origin. As the curve is symmetrical to y-axis, solving the equation for x. Solving the equation for x. Therefore, I will rewrite it. It is y into x square is equals to 8a cube. This one is 4a square y. Transferring to right, we get minus 4a square y. What we can take common from this two? We can take 4a square common. Here it remains 2a. If you multiply, we get 8a cube. Minus, from this if we take 4a square common, y remains. And then dividing by y, we get x square is equals to 4a square into 2a minus y divided by y. After solving it for x, try to get the values of y for which this term becomes negative. Therefore, there are again two terms of y, one in the numerator, another in the denominator. Therefore, if we consider this term from the denominator, if y is less than 0, negative, this become minus minus plus, and this become negative. X square is negative, and as x square is negative, if we take the square root, x is imaginary. Imaginary means curve does not exist. Therefore, for these values less than 0, negative values of y, curve does not exist. And second, another point is there, 2a minus y. From this we get, if y is greater than 2a, suppose 3a, 4a like this. If we put y is equals to 3a, suppose 2a minus 3a, once again x square is negative, this becomes negative, this one is negative, this one is positive, the resultant sign is negative, and therefore x is imaginary, and therefore curve does not exist for these two values, one y less than 0 and y greater than 2a. Means on this negative side curve does not exist, the values greater than 2a curve does not exist, means whatever the curve we have to complete, it is between x-axis and this line. And as this is the region where curve exists, we make a parallel part of that curve above this line. Therefore, I will make a parallel part here, symmetrical parallel part. Okay, as this line is asymptote, this line is a tangent, and as this line is tangent, the part of the curve we have to make a slightly parabolic. Okay, we make a slightly parabolic. Then curve exists between 0 to 2a, means we have to join these two parts smoothly, knowing that we are getting some values for y, and therefore don't join it by straight line because it is not a linear curve, it is non-linear curve. Therefore we join it smoothly, we get half part of the curve, and try to complete the symmetrical half part by joining this and therefore whatever the 5 points I have discussed, I have reflected it in this figure, and this figure is the tracing of this curve, which covers only the important point. What is that important point? First one is the symmetry. Here the curve is symmetrical about y-axis. Second point, whether the curve passes through origin or not. Here the curve is not passing through origin. Then third, point of intersection. Here we get the point of intersection as 0 to a on y-axis, and as a single point of contact, we find out the tangent at that point by shifting the origin. We get this line x-axis, or new x-axis, or line parallel to x-axis as the tangent, and as this line is tangent, I have made a part of the curve as a parabolic here. If we draw a parabolic, then and then only we get a single point of contact, otherwise it is not possible. Point number 4, asymptote. We are getting asymptote as y equals to 0. Y equals to 0 means x-axis. And the last point, region. Curve exists between x-axis and this line, and therefore we complete the figure in between these two by drawing this parallel part and this parabolic part, joining it smoothly, we get the required figure. Therefore this is the required figure of that tracing of that curve. Therefore, with the help of these two simple examples, I have explained how we can trace the curve for Cartesian equation. Some more I will discuss in the another part or second part for this curve tracing of Cartesian. Okay. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates or the new videos. Thank you. Thank you very much.